Computers need to be able to make decisions, and to do that, they make use of little chips, the simplest of which is arguably the operational amplifier. As the name suggests, the operational amplifier, the op-amp, amplifies, increases the size of the signal. It's used in a great many places, and in this lesson video, we're going to learn how it works. Well, actually, I might be overselling it a bit there, because the op-amp is what we call a black box. That means we don't know what's inside. We can look at the outside and see what it does, but we can't look inside. On the right, you can see a diagram of one, looking a bit like a spider with its 8 legs. On the left is the circuit diagram, with 5 connections, making it the most complex component we've looked at by a long way. It's not too bad though, because it only has 2 inputs and 1 output, plus a couple of connections to provide power, which we'll come to later. The picture shows 8 legs just because it's cheaper to mass produce sockets and chips with 8 legs than to make the correct number. So that's what it looks like. It's also really important to know the main property of an op-amp, that if the non-inverting input is more positive than the inverting input, the output is positive and very big. Write that down. Things are going to start getting complicated, but if you always come back to that main principle, you'll be fine. If the non-inverting input is more positive than the inverting input, the output is positive and very big. So, how does it work? I've got no idea. It's a black box. All we can say is that it's made from transistors, resistors, and other components. But that's okay. We don't need to know how it works. And I'm not just talking about for your exams here. I mean that in order for us to be good physicists, good engineers, we don't have to fully understand everything. Otherwise, where do we stop? No, it's a black box. We can't see inside, and we don't need to. The people who designed and built this thing designed it to behave in a certain way. All we should be doing is understanding what that behavior is. And from that, understanding how it behaves in a circuit. So, we should focus on understanding its properties, and using those properties, we want to predict what effect it has on a circuit. I'll go through the properties in another video. For now, let's look at the basic behavior. Now, I've already mentioned the main principle of how the op-amp works and tried to get you to write it down. What was it? If the non-inverting input is more positive than the inverting input, the output is positive and very big. It's best to think of the op-amp as 2 separate circuits. The left side has the inverting input, labelled with a minus sign. It is not always negative, it's inverting. More on that another time. The left hand side also has a non-inverting input labelled with a plus sign. We connect whatever we want to measure on the left to these 2. And then the magic of the op-amp looks at the potentials at these 2 terminals, and if the non-inverting input is more positive than the inverting input, the output is positive and very big. Now, that output is on the right hand side on a completely separate circuit. Just pretend that they are separate. It gets its power from the plus Vs and the minus Vs and provides output based on the comparison from the left side. That really is the basis of what this op-amp does. I won't lie though, it is going to get a lot more complicated than this. But if you take your time to understand and accept this basic behavior, it will make the rest a lot more easy to manage. In the next few videos, I'll be covering the designed properties of an ideal op-amp, and then we're going to start looking at a few circuits so we see how it actually works. But make sure for now that you really have what we've covered so far solid so that you're ready to continue.